Growth hormone releasing hormone, GHRH, also known as somatostatin or by several other names in its endogenous forms and as somatostatin, in its pharmaceutical form, is a releasing hormone of growth hormone, GH. It is a 44 amino acid peptide hormone produced in the arcuate nucleus of the hypothalamus. GHRH first appears in the human hypothalamus between 18 and 29 weeks of gestation, which corresponds to the start of production of growth hormone and other somatotropes in fetuses. Nomenclature: endogenous, somatostatin, somatoliberin. Growth hormone releasing hormone, GHRH or GHRH, HGNC symbol is GHRH. Growth hormone releasing factor, GHRF or GRF. Somatotropin releasing hormone, SRH. Somatotropin releasing factor, SRF. Pharmaceutical. Somatostatin, in. Origin. GHRH is released from neurosecretory nerve terminals of these arcuate neurons, and is carried by the hypothalamo-hypophyseal portal system to the anterior pituitary gland, where it stimulates growth hormone, GH, secretion by stimulating the growth hormone releasing hormone receptor. GHRH is released in a pulsatile manner, stimulating similar pulsatile release of GH. In addition, GHRH also promotes slow-wave sleep directly. Growth hormone is required for normal postnatal growth, bone growth, regulatory effects on protein, carbohydrate, and lipid metabolism. Effect: GHRH stimulates GH production and release by binding to the GHRH receptor, GHRHR, on cells in the anterior pituitary. Receptor. The GHRHR is a member of the secretin family of G protein-coupled receptors, and is located on chromosome 7. This protein is transmembranous with 7 folds, and its molecular weight is approximately 44 kd. Signal transduction. GHRH binding to GHRHR results in increased GH production mainly by the CAMP-dependent pathway, but also by the phospholipase C pathway, IP3/DAG pathway, and other minor pathways. The CAMP-dependent pathway is initiated by the binding of GHRH to its receptor, causing receptor conformation that activates GS-alpha subunit of the closely associated G protein complex on the intracellular side. This results in stimulation of membrane-bound adenylyl cyclase and increased intracellular cyclic adenosine monophosphate, CAMP. CAMP binds to and activates the regulatory subunits of protein kinase A, pKa, allowing the free catalytic subunits to translocate to the nucleus and phosphorylate the transcription factor CAMP response element binding protein, CREB. Phosphorylated CREB, together with its coactivators, P300 and CREB binding protein, CBP, enhances the transcription of GH by binding to CRES-CAMP response elements in the promoter region of the GH gene. It also increases transcription of the GHRHR gene, providing positive feedback. In the phospholipase C pathway, GHRH stimulates phospholipase C, PLC, through the beta-gamma complex of heterotrimeric G proteins. PLC activation produces both diacylglycerol, DAG, and inositol triphosphate, IP3, the latter leading to release of intracellular Ca2+ from the endoplasmic reticulum, increasing cytosolic Ca2+ concentration, resulting in vesicle fusion and release of secretory vesicles containing pre-made growth hormone. Some Ca2+ influx is also a direct action of CAMP, which is distinct from the usual CAMP-dependent pathway of activating protein kinase A. Activation of GHRHRs by GHRH also conveys opening of NAND channels by phosphatidylinositol 4,5-bisphosphate, causing cell depolarization. The resultant change in the intracellular voltage opens a voltage-dependent calcium channel, resulting in vesicle fusion and release of GH. Relationship of GHRH and somatostatin. The actions of GHRH are opposed by somatostatin, growth hormone inhibiting hormone. Somatostatin is released from neurosecretory nerve terminals of periventricular somatostatin neurons, and is carried by the hypothalamo-hypophyseal portal circulation to the anterior pituitary where it inhibits GH secretion. Somatostatin and GHRH are secreted in alternation, giving rise to the markedly pulsatile secretion of GH. Other functions. GHRH expression has been demonstrated in peripheral cells and tissues outside its main site in the hypothalamus, for example, in the pancreas, epithelial mucosa of the gastrointestinal tract and, pathologically, in tumor cells. Sequence. The amino acid sequence, 44 long, of human GHRH is HO, TIR, ALA, ASP, ALA, IL, PHE, THR, ASN, SIR, TIR, ARG, LIS, VAL, LU, GLY, GLN, LU, SIR, ALA, ARG, LIS, LU, LU, GLN, ASP, IL, MET, SIR, ARG, GLN, GLN, GLY, GLU, SIR, ASN, GLN, GLU, ARG, GLY, ALA, ARG, ALA, ARG, LU, NH2. Analogues. Growth hormone releasing hormone is the lead compound for a number of structural and functional analogues, such as pro-HGHRH, 1-44, GLY-GLY-cis, CJC1293, and CJC1295. Many GHRH analogues remain primarily research chemicals, although some have specific applications. Sermorelin, a functional peptide fragment of GHRH, has been used in the diagnosis of deficiencies in growth hormone secretion. Tesamorelin, under the trade name Egrifta, received U.S. Food and Drug Administration approval in 2010 for the treatment of lipodystrophy in HIV patients under highly active antiretroviral therapy, and, in 2011, was investigated for effects on certain cognitive tests in the elderly. As a category, the use of GHRH analogues by professional athletes may be prohibited by restrictions on doping in sport because they act as growth hormone secretagogues.
Please subscribe and thanks for watching.